Hello guys. Today's note will be over our sinusoidal graph. You need to know what an amplitude is, what a cycle is, and what a period is. For now, you can just read these three words and I will explain exactly what it is once I graph once I graph one of these functions. So let's go ahead and start with the first one. Using your calculator, what I want you to do is find 4 times the sine of 0 degrees and you should get 0. 4 times the sine of 90 degrees, you should get 4. 4 times the sine of 180 should be 0. Negative 4 here and 0. Once again, using your calculator, you can find this. And if you don't want to use your calculator, that's also possible if you remember the OI, I owe you, or I don't owe you. Or if you know the coordinates of your axis. Now, let's go ahead and plug in this point. Sine of 0 is 0. I'll put a dot here. Now, 4 times the sine of 90 is 4. So for 90, it's going to be at 4, meaning a point here. 0 again. Negative 4. And 0. And from here, all you have to do is connect the dots. So if you connect the dot, you should get something like this. It's going to make a little curvy line at that point. And another curvy one at this point. Now, this is just your sine function. Keep in mind, it doesn't stop here. It should continue on both sides. The reason I kept this point red is because it's a very important point. The sine function usually goes through the point 0. If I was to grade how well you graph this, I should look at the starting point always. Now, the amplitude of this y equals 4, since theta is 4. Why is theta 4? The reason we say theta, the amplitude is 4 is because the definition of amplitude is the distance between the sinusoidal line and the highest or lowest point. This line here in this specific example, the x-axis is your sinusoidal. So your sinusoidal line, and this is your highest point at 4 or at negative 4. Therefore, this distance represents your amplitude. Usually we call it A as well. So your amplitude is 4. The next thing you need to know also is the cycle and the period. I will get to it right away. Now, to know the period is when you make a complete cycle. So the period is not just from here to here, but it's from this point when you end at the same exact point. Not here, but here. So if I cut this portion and I copy it, paste it here, it should make the exact same shape. So from 0 to 360, I will say that my period is 360 degrees. A full cycle is from here to here, but the period is the degree value of cycle. Alright, let's go ahead and move on to the next one. Once again, it's very identical to the first one. This time we're in radians. If you plug these values on the calculator, or you can just plug this one on the calculator and go on the table, you should be able to get these values. But the values should be 3, 0, negative 3, 0, and 3 again. Let's go ahead and plug in the points. The first one is 0, 3. The second one should be pi over 2, 0. Then it should go to negative 3, go back to 0, and all the way this. Now, let's go ahead and graph it. If you graph this, you should get something like this. Now, this represents my full period. My period is, if I cut this and I paste it back here, it will start again here and all here. So my period here is from 0 all the way to 2 pi, meaning 2 pi. The amplitude is usually the value that is sitting right in front of the trig function, meaning 3 for example here. But let's go ahead and check. The amplitude is from the sinusoid, the line, all the way till the highest or the lowest point, and the distance here is once again 3. So my amplitude is this distance, which is 3. Now that you've seen two examples, you should understand that the graph of y equals a sine theta has an amplitude of a. All the amplitude again is a vertical, usually what you call vertical stretch. Alright, let's go ahead and graph one that is slightly different. This time we have y equals sine of 3 theta. The 3 is inside of the parentheses if I were to have parentheses here. If 3 theta is equal to 0, then theta is 0. If 3 theta is equal to 90, then theta is 30. If you complete this, you should get 60, 90, and 100. Now, y equals sine 3 theta. Sine 3 times theta, or sine 0 here, is 0. You should get 1, 0 again, negative 1, and 0. Let's go ahead and try to graph it. 0, 0 start here. Of course, whenever it's sine, it starts at the origin. If it was cosine, it will start on the axis, high up there or low down here, either here or here. But sine usually start at the origin. So I have 0 for 30 is 1. Should go back to 0, negative 1, 0. You should memorize this shape, this sinusoidal function. You should memorize how it looks like, because we keep using it over and over again. And this will be our graph. Always have a little extra continue on each side to tell me that it will keep going. Now, this is my 60, this is my 120. If I were to ask you what is the amplitude is the distance from this. It would not always be the axis, but for this problem, we have again the axis. From this line all the way to the highest point, that distance is 1. So we have amplitude of is 1. Sorry, I wrote it on the period. So I will say amplitude is equal to 1. The period of the y equals sine 3 theta is from 0 all the way till when we start repeating our stuff, meaning all the way till 120. From 0 to 120, we have 120 degrees. I'll do another one. By the way, there's a critical high and low or middle point. You should be able to answer this. High, low, or middle point. From this to this, we have a middle point, which is the highest point. Then we have highest point, middle point, lowest point, and back again to the original or the starting point. So it's every 30, because from here to here we have a critical point. Another critical point is every 30 degrees. It's important to know how often you get a critical point, because it helps you graph your sinusoidal function. Let's do one now with cosine. As soon as I see cosine, I know I'm starting high up there or high or lower down here. Now, the value in front of the cosine tell me the amplitude, so I know I'm starting somewhere here. But let's go ahead and check. 2 times 0 is 0. Pi over 2, that will give me pi over 4 now. This one will give me pi over 2. This one will give me 3 pi over 4. And if you continue, you get to pi. On this side, the cosine of 0 will end up being 1, 0, negative 1, 0, and 1. This whole unit is non-calculator, by the way, so you should be able to get these values without a calculator. Just as predicted, we know it starts at 1, and the next critical point will be pi over 4, which is at 0. So I will label this one pi over 4. And if this is pi over 4, 2 times pi over 4 will give me pi over 2. Then if I add another pi over 4, I get 3 pi over 4. Add another pi over 4, it's 4 pi over 4, which is pi. Let's go ahead and have the first point is here, the second one is here. The third one is a critical point, but this is the lowest point. It will go back to 0 and be high up here. So graphing it will give me something like this. You should be able to graph it better than I can. Alright, what is the amplitude? We predicted it was from 0 to 1, especially since there's a 1 in front of the trig function. So the amplitude is 1. Now the period is from where we started to where we end. We started here. A full cycle will take us here. So the period here is pi. I meant pi. Now, there's a critical point every, we need to check. Every from 0, here's pi over 4, here's pi over 2. Obviously, it's every pi over 4 units, knowing that this is 0, of course. Now, the period of y equal cosine b theta, if you look on the bottom, the period of y equal cosine b theta is, based on what you have seen here, when it's cosine 2 theta, the period is pi. In other words, the period here is pi when it's cosine 2x. If you look up here, when it's sine 3 theta, the period is 120. There's a correlation between the value in front of theta and the period. That correlation is as follows. The period of y cosine b theta is always 360 over b. B being the value in front of the theta. So for cosine 2x, note that it's the same thing also as 2 pi over b. In case we're in radian, in case we're in degrees. So this one was in radian, for example. To find the period, knowing that b here, the value of b was 2, all I have to do is say 2 pi over 2. And if you simplify, you get it back to your pi. And there's a critical point every period over 4. So to find out the critical point, I would say it's 360 over 4b, which is the same thing as 90 over b. Regardless of what b is, if you divide 90 by b, it tells you exactly where you have a critical point. Alright, let's go ahead and practice with this problem. It says y is equal to 6 cosine 5 theta degrees. The first thing you have to understand is the amplitude is 6. So for this type of problem, once again, we will be able to move the sinusoidal line. But on this problem that we have in front of us, the sinusoidal line remains the axis. So let's go ahead and start by analyzing it. By now, you should know that the 6 represents your amplitude. Now, knowing that it's a cosine function, you're starting up or down, and it's a positive, so you're starting up at 6. So I can label this as, this will be 3, this will be 6. Therefore, this is -3, and this is -6. I know how to label it based on my amplitude. And I know I'm starting high up here at 6. The next thing you should analyze is this 5 that is located. So as of right now, we know the amplitude is 6. The 5 that is located in front of the theta will help us identify the period. So I will say the period is equal to, remember, it's 360 over b. b here is 5, so 360 over 5. And 360 divided by 5 should give you 72 degrees. Here I can say a is equal to 6, b is equal to 5. Now that's not it. We also need a critical point. We usually call it CP. The critical point is equal to 90 degrees divided by 90 degrees, of course, divided by the value of b. So I will say 90 over b, which is 5. And you divide 90 by 5, you should get 18 degrees. So I have a critical point every 18. Knowing that I have a critical point every 18, I will label my axis every 18 degrees. So the first one is 18, following 36, 54, and 72, 90, 108, 126, and the last one will be 144 degrees for now. We will see if that's enough to make 2 complete cycles. Knowing that I'm starting at 6, this is what I will do. I know that if the first one is high, the second one should go through the middle, third one through the bottom. It will keep making this shape over and over again. That's why I was saying earlier, make sure you memorize this shape. So let's go ahead and graph it. If we do something like this, make sure it goes through your points. Don't be like me. If it goes through the points, that would be wonderful. All right. Once again, if it's a cosine function, it starts up here. Sine function, it starts usually at the middle. Cosine can also start on the bottom. Let's now see if we have 2 complete cycles. Cycle is from one point. When you go back to the exact point, that will be 1 cycle. We have 2 complete cycles. As I said before, continue a bit on both sides. And don't continue. When you continue using the same type of shape. All right, one more, and we're gonna get to something a little more different. For this one, it's a sine function. So where do I start? Obviously, I start at the origin. Sine functions usually starts at the origin. The amplitude is 8, so I need 8 above, 8 below. So here would be, I assume, 8 and negative 8. Of course, you can put negative 4 here and 4 there. It's up to you. Now, since it's positive, it means that I'm going up after. So let's first say amplitude is 8. The period is equal to 2 pi over 1/2, which is equal to, of course, 4 pi. And the critical point is 90. Actually, instead of 90, I would say pi over 2. Or let's just do 2 pi over 4b. 2b, I'm sorry. 4b here. I will rewrite it for you. The critical point is 2 pi over 4b. So if I have 2 pi over 4 times 1/2, that will end up being pi. So I'm putting pi everywhere here. So this is pi, this is 2 pi, 3 pi, 4 pi, 5, 6, 7, and 8 pi's. Since the amplitude, the value, the sign in front of the amplitude is positive, it means that from the starting point you would be going up. So you would go up first, and of course you're going to reach a point here, which is again another critical point. And once again we follow the same shape: high, middle, low, middle, high, and so on. So the shape should look like this. Your hand should not be shaking as much as mine is. And of course at the end you got to continue a little bit on both sides. Now, did we complete full cycles? The first cycle we start here, you will travel and stop here. The second cycle we do same shape. So we completed 2 cycles. Alright, let's do this real quick. Consider the parent function y equals sine theta. Describe the transformation. If y is equal to 5 plus sine theta, you should understand that you go up 5. This was on your first after party, but using a different function. This one, of course, is down 3. If it's inside the parenthesis, it's moving left and right. The positive one will move to the left 50, and the negative one should move to the right 3 pi over 4. Alright, compare and contrast the graph of y equals sine theta to the graph of y equals negative sine theta. Now, if you have both graphs, y equals sine theta, they both first will start at the origin. The first one that is positive will be going up, down, down. Compared to the other one, will be coming from the origin as well, but starting going down. If you notice, these two graphs are symmetry. That's the reflection over the line over the x-axis. So I would say a vertical reflection. The same thing will happen with the cosine. The only difference is the cosine function starts on the axis, meaning here. And here we go. The first one will be going down, up. Compared to the other one, it will start on the bottom, so it will go like this, crossing the same point, by the way. So one start up, the other one start down. Describe the effect of A, B, C, and D. If you don't have this, then you have you don't have anything. This is the most important information here. A represents, we've studied it already, is the amplitude. And if, of course, there's a negative in front of A, it can be a reflection. Negative just means what? Reflection. Now, B is your period. Well, it's not quite the period, but it will help you find the period if you use the formula that says 360 over B. And it will also help you to find the critical point. The CP here will be 360 over 4B. Now for C is the vertical shift. C represents your vertical shift. You will know that positive, let's just write vertical first. Since it's your vertical shift, positive is up, negative is down. And D is your horizontal shift. Where the positive goes to the left, and the negative will take you to the right. You have to memorize this. Find a way to memorize this, because if you don't know this, you will struggle to graph. You can stop at this point. I will make a separate video for the second portion of your notes.